Okay, here we go. Looking at our chart here, we want to be able to write the ordered pair for each point shown to the right and the quadrant that we're getting. Okay, what quadrant is in? 3. What about B? C?
4.
D?
2.
E? X-axis. F? Those are our quadrants. What about our coordinate points for A? B. 3, 2. C. D. E. 2, 0. And quadrant 4. Boom. Okay, just to review that kind of stuff. Okay, you'll see a lot more of it when we get more into the graphing portion of it. Okay, are we good? Take out your notes. We're going to be taking notes for just a little bit. Nothing too crazy. Do me a favor and copy down the following. Copy it all down. Everything. Yes, it's just this one. The other ones are going to be very just the graph, just the table.
Take my quiz.
Not during tomorrow. I have practice tomorrow.
Wednesday?
Tomorrow, in the morning or lunch? Morning or lunch. When talking about the rate of change, we've already seen a lot of these already. Here, we've looked at tables, and we know the rate of change is essentially our slope. The only difference with rate of change is it's just expressed as a unit. Okay, miles per hour, gallons per minute, temperature per minute. Okay, so we just have it as a ratio or a fraction. Nope, stop. So rate of change describes one quantity changes in relation to another. The rate of change is usually expressed as a unit rate. Okay. We're just going to set this one very simply. The table shows the amount of money Booster Club made washing cars for a fundraiser. Use the information to find out the rate of change in dollars per car. So that's what we're going to do. So copy. Copy the table too. Everything. Yeah, the whole thing. It's only one that we're going to have an explanation for. Everything else, we're just going to find the rate of change and just solve and explain what it means. So I just want you to have one good example. That's all. Yes. Everything. Copy everything down. Everything and everything on that page. The words, the table, everything. It's the only one that we're going to be doing fully. Everything else, I'm just going to have you draw the table. So, are we good to go? We're looking at the rate of change. It's basically we want to find the differences between each point. We're given a set of values that talks about the numbers of car washed and then money raised by it. Okay, some of you guys are able to see what was happening with these, and it's good. What's happening with the number of cars? How much am I increasing by each number of cars? 5, right? 10 to 15 is 15 to 20 is 5. Okay. So we see an increase of 5 every time. If we do the same thing for money, how much are we increasing by? 40 and 40. Okay. To identify our rate of change, we always know the rate of change is the same thing as slope. So our slope is what? Y's over the x's, right? So what would be my ratio for my rate of change? 40 over 5. That is, for every $40, we get I have to wash 5 cars. Can that be reduced to what? 20 over 1? 8 over 1. Okay? This is the context of the problem that we want to have it in. Okay? Because it's asking us, use the information to find the rate of change of dollars per car. So can you put that in context of money and the expression? What is it asking us? What does that rate of change tell me? Per car, right? So we get $8 per every 1 car. Okay, and that's the context of the problem that we want to put it in. Okay? We want to be able to identify those values. Does that make sense? That's all we're doing. We're gonna add on to that, but that's all we want to see. This is kind of like the beginning of word problems. Okay, this is what we want to see. You guys have only one word problem on your guys' paper. We're going to review it. I want you guys to do it today, and then we're going to review it tomorrow. It should be very straightforward. Okay? Do me a favor and copy down the following table. Okay, copy down that. You don't need to copy down the words up on the top. Just copy down the table. Okay? It says the table shows the number of planes traveled or the number of miles a plane travels while in flight. Use the information to approximate the change in miles per minute. Okay, so we got to find how far does a plane travel per every 1 minute. And that's what we're going to do. So looking at this one, what do you think our input is? What's my x in this case? My time. My time. You're right. You're right. How much is it increasing by from 30 to 60? 60 to 90? So it's giving us in increments of 30 minutes per take. What about our distance? Our distance is considered our y, our output. So what are we getting from 290 to 580? 290. 580 to 870. And so we're getting an increase in 290 for every 30 minutes. Can we write that as a ratio or a rate of change? What would it be? 290 over 30. Can someone give me in the context of what we've been doing in words, what's that? What does that 290 over 30 mean? Yes. What does it mean? $290 miles. Let's see how that looks when we reduce it down. The first thing we can do is reduce down by just doing these two, right? Cutting down the zeros. So what does this again tell me? For every 29 miles we go, it takes us 3 minutes. Okay? But we want to put it in context of 1. Okay? And it's simply, what we're simply going to do is divide it. What's 290 or 29 into 3? 9.6. So I'm going to reduce that and keep it over 1. Okay? Basically what we did is we divided both the top and the bottom by 3. It can give us a decimal. I'm okay with that. Well, what does that now tell me? if I wanted to put it in the way that the rate of change, 1 unit of measure, what would that mean? For every 9.6 miles traveled, it's taking us what? 1 minute. That's pretty fast. That's pretty fast. Traveling 60 miles an hour in a car, for every 1 minute you travel 1 mile. So in this case, for every 1 mile, traveling almost 10 times that speed, which should make sense because you're in a plane, right? That's still pretty fast. Still pretty fast. Okay. Cool? You see what I'm trying to do here? Okay. That's what I want you guys to be able to do, is be able to convert the units, reduce as much as you can, and convert it. Tell me what it means. Okay. For the next two, we have about 4 more left, and that's it. Okay, copy numbers 2 and find the rate of change, and give me the explanation for them. Okay, we're going to kind of look at them as well. This talks about distance and time. And the other one is time and wages. Looking at that, would you work for that amount of money per hour? Let's see. We'll see. So try those out for me really quick. Although I don't know what the difference between a CG apple and a no, but there was 2 different words. It looked exactly the same. And one was gallon. I don't know the difference. What's the difference? In what? These are. Huh? Frozen grapes. Those are bomb. I don't know the difference. Yeah. Yeah. What's my rate of change for number 4? For X's? What about my distance? In context, what's my ratio? Let's go with that. 6/1. What about an explanation? What does that mean? 4/4. 6 meters for every 1 second. You looked at the next one. In retrospect, how much is 6 meters? What's a meter? 3 feet. So 3 times 8 is what? 18 feet for every 1 second. That's pretty fast too. Maybe I would say in perspective, maybe bicycling really fast. I don't know if someone can run 18 feet in one place. From here to at a full sprint, yeah, maybe. But maybe 18 feet. 18 feet is, let's see. 18 feet is probably the length of this room. 1 second to get there running. You would have to be at full sprint running. But maybe, I don't know. That's pretty fast still. That's why I kind of said a bicycle going full speed. That's possible. Okay, what about the next one? Hold on. What about the next one? What's my rate of change for hours? So what's my slope? So what does that mean? $9 per 1 hour. How many of you guys would work for $9 an hour? You're gonna go far. You're gonna go far in life. My first job, I was telling my other classes, my first job, it was under the table. I was 15 and a half, 16, freshman in high school. You know how much I was getting paid? Mind you, I was working on a ranch. Yeah, so I was getting paid $5 an hour. $5? That was pretty baller. Okay. 8 hours, about 8 hours. It was under the table, so I was doing it at night. After I was on football practice, go right over. It was crazy. Yes. Yeah, but I didn't work. It didn't work like full time. It was only when I needed. I shoveled manure, lifted hay, threw hay downs, put in posts, cut down trees. It was crazy. Okay, looking at this one. Okay, this is going to be towards your homework. So look at this. Copy down that one. We're going to look at another table as well. We'll look at
First one and go down to 9, 11.
Oh, wow. Thanks for pointing that out, man.
There's numbers.
9, 11. Did you not realize that you did this?
It's too bad. So copy those two down. This is just reviewing kind of what we're going to do for your homework. There was a lot of questions done by today, so I'm going to try to X them all out. Huh? Okay, looking at number 1, what's my rate of change for my x's? What about my change in y's? -3. Do we consider this linear? Yeah. We're getting the same ratio every single time. What would be my ratio for each one of those? -3/2. Okay. Definitely not trying to confuse you guys. It's just basically -3/2. It is linear. My slope is -3/2, and that's going to be what we're looking at. Okay. But just because the ratios are always the same, okay, we can have different ratios and get the same outcome. If I do it for the next one over here, what's my change in my x for the first one? +3, 0 to 6. plus 6, 6 to 9, 9 to 12. Now, do I stop there? Is it linear? I got to keep on going, right? Okay. Just because one side does not equal 2 and 2 all the way down, we got to make sure that everything is correct. As long as we have the same ratios, we're okay. If I do it to the other side, y goes from 2 to 4 by 2 to 8 by 8 to 10 by and 10 by 2. We got to be able to see if our ratios are all good. What would be my first pair right here? 2 over 3. What about the next one? 4 over 6. Can that be reduced to what? 2 over 3? And 2 over 3. Are all of our ratios the same? So is it still linear? So we're good. Okay. If it was off by one of them, we would say, no, it's not linear. No, we can't find that out. Does that make sense? So we want to be able to determine whether those are the same. This is the last part. This is the last part that we're going to be doing. You guys ready? We're good? We're good? See a couple more people writing. Okay. Do me a favor and copy down this chart. We're going to look at this one and just one more. Copy down everything. Copy down the words. Okay. Because in this table, we're missing values. We're missing values in this table. Missing parts of a table. We know we want to be able to see that the ratio is going to be the same for every single term that we go down. If we're looking at this one, can I determine the rate of change by doing the first two? No. So the first two is not going to help us out. But I know my rate of change should be constant for all my x's. So use another two pair to figure that out. If I go 6 to 7, what's my rate from 6 to 7? What about from 7 to 8? So what should be my rate of change for x? 1. You keep on adding 1. So from 4 to 6, or from 4 to our next one, it should be adding 1, so it should be what? So that's my input. We're going to do the same thing to y. My rate of change from 10 to 12 is, I'm going to be able to use that. 12 to 14. So that means 14 to my next one should be 16. It should be increasing by 2 every time. Can I find my ratio? What's my rate of change? 2 over 1. It is linear. It is linear. And that's all what you want to be able to do. But I'm going to give you guys another one. And please copy this. Give me a second. I'll tell you when to start copying. Okay? But I want you guys to try the following. So we're going to clear it. So do me a favor and write down. Let's do. Let's do this. Let's do I forgot what my other one looked like. And let's say this one was. Let's look at this one. Copy down this one. Okay. So we're still missing, and we got to still determine whether it's linear or not. Okay. We're going to try to fill in our gaps by looking at what we're increasing by every single time. And we're going to still determine whether this is correct or not. We can still do that. Okay. Looking at our x's, what are we increasing by? What's our rate of change? 5 to 6. So I should get from 6 to the next one should be 7. And then if this is 7, sorry, mess that one up really bad. And then from 7 to 10, I'm increasing by what? Okay. That's not going to help us determine up yet, but I can still fill in that information by what it's providing me for. Okay. What about for my y's? What am I increasing by from? Can I use the first two? No. So I got to skip that one. And we're going to go 14 and 16 is done by. 16 and 18 is done by. So I know that our rate of change should be. So 10 to 12 should, or 10 to plus 2 should be. But is it linear? Why? What is my first ratios that I'm getting for a bunch of these? We're getting 2 over 1 for the first pair, 2 over 1 for the second. What happens to my last pair here? So is it linear? So what should I put down? None. Non-linear? None? None. Does that make sense? So you got to be able to determine those ratios as we do them. You guys ready for your homework? That's all we're doing today. That's all we're doing today. You guys still have 17 more minutes left. That's plenty of time to do it. Yes, sir. It's wiser risks. So in this case, well, in this case, for a four, we're still using what about 2%? So we have this 2%. It's negative 0. Those 2 ones, 4 0. So there's 2. 41. 2. So we know the ratio of our percentage. If they reduce our same one. In this case,
Oh, no. I know. Yeah. Oh.
there's no ratio, our ratios are the same.
Yeah.
Good. I'm nice to you guys. Blessing you guys. I know you guys are so excited. I'm just so excited. We decided on
What?
So we were so we talked about
I know. When they're two, doesn't mean that they should try to go to the next level. They don't want to do it.
she's like 7 or 8.
I think
But it's more so like showing you kind of, okay.
Dude, that's why, like, I woke up, I was like, oh, I saw it, followed you for 3. I woke up, I was like, oh. She was very
I think I can crack it and fix it.
So why did you stay there?
I feel I remember last week, I just remember waking up and being like,
when he gives him the shot, like that, just trying to, he was painful. The doctor had to pull it out. He's like, "Are you okay?" And by this time, I was 6 years old. And my dad's like, "See, I'm just messing with you guys. It's nothing." We're crying now. My dad's traumatized us. Traumatized. No, I
It's terrifying to me. So when they were gonna give it.
it was horrible. See, then you should,
My mother was different.
I used to give plasma. So you just- Your blood is separated really fast. White, red, plasma. They suck the blood out of the tube and they put it in the center. To separate it. And they push back all the blood. So they put I got and then $75 for the first couple days.
I was just like, oh, let's check.
We're just sitting.
Yeah, dude, I was like, bro, I was not expecting that.
Your body.
Yo, that was a good throw.
She was like, she wants to kill you
All right,
already.
because you're concerned with watch.
I said, hey,
Thanks for
you there.
Let me see what yours.
all your shots. There's a lot of.
I mean,
As I started doing it a lot, I just it looked like shot up. But then so therefore, it's 6 months.
Oh no, they play that song. 1, 2, 3.
They had to do that to me at hours. But I had to get it just.
Dude, we're actually not crazy though. It's like I didn't think Oso's kids were actually going to be that fun. I didn't think Oso's kids were even going to be that fun. No, dude, there's actually black kids. That's how I was surprised about it.
What's everybody saying? Let's see how are these guys?
Yeah, like, oh, you said that.
I told him, he didn't know it.
I switched out. But it was like so
You never
awkward.
noticed
I saw you were there, and then like I just like didn't go. Yeah, no one cares.
Damn. Wait, when did you go to the school? Oh my. I know her name.
Santa's place.
Sit down.
Waiting for everyone to sit down. I'm waiting, guys. I'm waiting. Bye. look at her. She's wishes.
Happy kindness week.
Hey, I got your stuff. Happy Kindness Week.
Thank you.
I'll
bring them back.
With
Have a good lunch.
we'll see you, Sharon. Like it goes on and off. Okay. Okay. I don't even know how to coach it.
Oh my gosh, she said that? To you?
Fuck off.
To you?
Yeah. But I know she got me inside. But that's what she said right now. That's why everyone was like looking at her like she said it right now. Yeah. Yeah.
Sorry.
Are you okay?
Yeah, it's just my things.
It's okay.
No.
She said it now.
She says sorry right away.
Yeah.
Interesting.
Yeah. I knew one of my dad's friends used to do that. And like,
I would
Like, you was
lie.
mad.
I would
when
lie.
my dad said it was the first time he walked in because it was my dad, because my dad was his manager.
I wonder if why it's like those like bad words that
Yeah.
that comes like.
I don't know.
No?
I don't know. Like, is there good, like, a polite prince? Like, looking good. You know? Like,
Oh my gosh, you're hilarious. Is there a polite?
is there like polite prince?
But no, that's why I'm wondering, like, why it triggers like badly.
Yeah.
You know? What's up?
So,
I don't have money, dude. I really don't. You have money, and
I don't have any money, dude.
yeah, you do.
I only have like $200.
200. All right, there you go.
But I don't have a resume.
Is Alexis here? Do you know? Yeah, don't, dude. If you, I swear, if you drink it all, I'm gonna be pissed. Girl, take a sip. That's all. A sip. Okay. Peach tea.
Just getting a taste for it, bro. Dang.
There you go. That's
I get free food from Chili's every night, bro. Chill
Oh
out.
yeah. 50% off. That's not free.
Bro.
Bro.
What's the most expensive thing I think like 50% off is what, $9? Bro, you have okay, we had to do something in French. Oh my god. Yeah, okay, so I forgot what number it was, but it was like 263, like 60%, 19 cents or something like that. So it was like a 200 Sazon 3.
Can you text Lexi and see if she's here? Because she has my sweater and her
Wow. Call her, you got her phone?
No.
Okay, so I said, so it's like, do song, Swazo,
Do people speak it really good in there?
oh, I'm like wondering, I'm pretty good in this.
Yeah, you seem pretty good. You want string cheese?
Yeah, I don't speak it, but you know, spelling is easy, because like, I do it a lot. So.
That's good. Did you ask him about your missing assignments?
No, in your time, you should be doing it.
Okay, after this class, you can go up to him.
So we have do the song, Swazo,
I don't know what to do with that.
I don't think they're coming in here today, but if they walk in, I'm gonna start having them. I'm not taking them home anymore. Just as this. I'll give a fuck, honestly. And, They're gonna be with their schools. Summit. You can take the bus. I'll be taking them home. Not be here. So I don't know where. She doesn't want to come back for me, so I'm not gonna come back for her.
What does she need?
Like, I work 2 jobs, and she doesn't give a shit that I don't want to sleep for 4 hours a day. I go out of my way. You know, Montana's not close. I mean, it's a drive to go over there. So I drive over there. They go and sit in one gas card and get in school for what, 4 months. And I'm not asking for money, but it's like, it's not even about that. It's about my sleep. I leave here. I take everybody home. By the time I get back to the dining bar, I have to get ready for my other job. So I have no time for myself. I'm just work, and then doing it all over. So they're probably not going to come over. But I want my starter back, so that's why I asked for it. And all of a sudden they have a right to do it, just because Jessica just called me yesterday.
What time does she have work?
Her, she gets off at like 5, and I told her, oh, why don't I just take the kids to my house and bring them back here? Oh no, Michael wants them home right away. Why? Because of the dogs.
You didn't know.
And the baby was home. So, I said, you and Jayla come first. Yeah, you can stay home and Jayla, I hardly ever have to. So it's like, no, they don't need to come home. You should trust. No, it doesn't. I mean, that's on them. You know, I gave them options to nothing else. It's not my problem that they don't do it, you know. Like they're not.
Over some dogs, during the week, some dogs. Oh, it's been long.
Did you get scared right now?
Uh-huh. I did a mile by 4 seconds. I did a mile by 4 seconds.